In this video, we will learn the motion of the center of gravity of any body. But before we proceed, let us first define the center of gravity. The center of gravity of a body is the average location through which the resultant weight of all particles of the body is acting. We know that a body is composed of many particles, and each of these particles has their own weight. The center of gravity is the point where the resultant of these weights will act on the body. Since the criterion of size is relative, when you treat a body as a single particle, its motion is referenced on the change in position of the center of gravity if an external force will act on it, causing its acceleration or deceleration. Consider a flat body. When the resultant of external forces that act on the body is passing through the center of gravity of the body being considered, the path of motion will be passing along the center of gravity, collinear with the line of action of the resultant force. In this case, there is no rotation. Remember that the direction of the resultant external force will dictate the direction of motion. And if the direction of the resultant force is constant, the motion path of all particles will be straight lines parallel with each other, and this is called rectilinear translation. If the direction of the resultant passing the center of gravity of the body is varying, the motion path will be a curved line called curvilinear translation or curvilinear motion. Remember that the external force resultant that will act on the body will still pass through the center of gravity of that body. It is also important to remember that in curvilinear translation, although the direction or sense of the force is varying, there will still be no rotation. If the resultant of external forces is a couple, the body will rotate about the vertical axis, while the center of gravity is remaining stationary, meaning there is no translation. All particles of the body along a straight line passing the center of gravity will have the same angular displacement but different circular arc length displacement. Consider these two particles in the figure. The blue particle and the red particle are both part of the same body under rotation, and the red particle is closer to the center of gravity of the body. If the blue particle and the red particle will travel from this axis to this horizontal axis, they will travel the same angle, or they will have the same angular displacement. But it is noticeable that the blue particle will travel a greater arc length as compared with the one traveled by the red particle. If the resultant force will not pass through the center of gravity of the body, the motion can be described as a combination of translation and centroidal rotation, and it is called a plane motion. As I recall, the center of gravity of a body is the average location through which the resultant weight of all particles of the body is acting. And since the force is the one that causes motion, changing the location of the application of forces with respect to the position of the center of gravity also changes the type of motion of a particle or a body. Thanks for watching! If you like this video, don't forget to hit the like and subscribe button and turn on the notification bell.